Dear friends, this video shows the architecture of long-term evolution, LTE, technology. Please like the video and subscribe the channel.
Long-term evolution, LTE, is the evolution of the Universal Mobile Telecommunications System, UMTS. System Architecture Evolution, SAE, comprises of three components. First is User Equipment, UE. And second is Evolved, UMTS Terrestrial Radio Access Network, EUTRAN. And finally third is Evolved Packet Core, EPC. When we combine together LTE and SAE, it comprises Evolved Packet System EPS. EPS provides the user with IP connectivity to a packet data network, PDN, for accessing the Internet as well as for running services like Voice over IP, VoIP. EPS uses the concept of EPS bearers to route IP traffic from a gateway in the packet data network to the user equipment. A bearer is an IP packet flow with a defined quality of service, QoS, between the gateway and the user equipment. Let's have a look on user equipments.
User equipment is any type of device used by an end user to communicate. User equipments can be held smartphones, a laptop computer equipped with a mobile broadband adapter or any devices. The user equipment consists three components. First is mobile termination, MT, this handles all the communication functions. Second is terminal equipment, TE, this terminates the data streams. Third is universal integrated circuit card, this is also known as the SIM card for LTE equipments. It runs an application known as the Universal Subscriber Identity Module USIM. User equipment handles the below-mentioned tasks towards the core network. First is mobility management. Second is call control. Third is session management. And fourth is identity management.
Let's have a look on eNode B.
eNode B is a base station that controls the mobiles in one or more cells. The main functions supported by eNode B are: the eNode B sends and receives radio transmissions to all the mobiles using the analog and digital signal processing functions of the LTE air interface. The eNode B controls the low-level operations of all its mobiles, by sending them signaling messages such as hand-over commands. Each eNode B connects with the EPC, MME, by means of the S1 interface and nearby base stations by the X2 interface, which is mainly used for signaling and packet forwarding during handover. Access network is responsible for the below-mentioned functions. First is radio resource management, RRM. Functions are radio bearers, such as radio bearer control, radio admission control, radio mobility control, scheduling and dynamic allocation of resources to user equipments in both uplink and downlink. Second is header compression. It helps to ensure efficient use of the radio interface by compressing the IP packet headers that could otherwise represent a significant overhead, especially for small packets such as VoIP. Third is security. All data sent over the radio interface is encrypted. Fourth is connectivity to the EPC. This consists of the signaling towards MME and the bearer path towards the serving gateway.
Let's have a look on Mobility Management Entity, MME.
The Mobility Management Entity, MME, is the control node that processes the signaling between user equipments and core network. The functions of MME are: firstly, MME involved in the bearer activation, deactivation process and is also responsible for choosing the serving gateway and for user equipment at the initial attach and at the time of intra-LTE handover involving core network node relocation. Secondly, MME provides packet data network gateway selection for the subscriber to connect to PDN. Thirdly, MME provides idle mode user equipment tracking and paging procedure including transmissions. Fourth is MME chooses the appropriate serving gateway for user equipment. MME is responsible for authenticating the user by interacting with the HSS. MME works as termination point for non-access stratum (NAS) signaling. MME is responsible for generation and allocation of temporary identities to user equipments. MME checks the authorization of the user equipment to comp on the service provider's public landline network (PLMN), and enforces UE roaming restrictions. The MME is the termination point in the network for ciphering, integrity protection for NAS signaling, and handles the security key management. MME communicates with the MMEs in the same PLMN or on different PLMSs. The S10 interface is used for MME relocation and MME to MME information transfer or handoff. The MME provides the control plane function for mobility between LTE and GSM/WCDMA access networks, with the S3 interface terminating at the MME from the SGSN.
Let's have a look on Serving Gateway, SGW.
The Serving Gateway, SGW, is a critical network function for the 4G mobile core network, known as the Evolved Packet Core, EPC. The SGW resides in the user plane, where it forwards and routes packets to and from the eNode B and PDN gateway. The SGW also serves as the local mobility anchor for inter-eNode B handover and mobility between 3GPP networks. SGW can be a standalone element or integrated with other EPC elements, such as: first is Mobility Management Entity, MME. Second is Packet Data Network Gateway, PGW. Third is Release 8 Serving GPRS Support Node, SGSN. Serving Gateway, Mobility and Session Management Interworking. The SGW can also be integrated with 2G/3G elements, such as the Serving GPRS Support Node, SGSN, and Gateway GPRS Support Node, GGSN. This integration is critical to mobility and session management interworking between 2G/3G and 4G mobile networks. By combining multiple functions into a single carrier class platform, operators can reduce signaling overhead, better plane performance, distribute session management, and take full advantage of the control and user plane capabilities. SGW primary features. First is integration of multiple core network functions in a single node. High performance across all parameters: signaling, throughput, density, and latency. Second is integrated intelligence, and the SGW supports intelligent paging and prioritization. Third is high availability, ensures subscriber satisfaction and 99.999% system availability.
Let's have a look on Packet Data Network Gateway, PGW.
The Packet Data Network, PDN, Gateway, PGW, is a critical network function for the 4G mobile core network, known as the Evolved Packet Core, EPC. The PGW acts as the interface between the 3GPP2 Long-Term Evolution System Architecture Evolution, LTE SAE, network and other packet data networks, such as the Internet, SIP-based IP Multimedia Subsystem, IMS, networks, and Evolved High-Rate Packet Data, EHRPD, wireless data networks. PGW acts as the anchor for mobility between 3GPP and non-3GPP technologies such as WiMAX and 3GPP2, CDMA1X and DVDO. PGW functions include: mobility anchor for mobility between 3GPP access systems and non-3GPP access systems. This is sometimes referred to as the SAE anchor function. Policy enforcement, gating and rate enforcement. Per user-based packet filtering, deep packet inspection. Charging support. Lawful interception. User equipment IP address allocation. Packet screening. Transport level packet marking in the downlink. Downlink rate enforcement based on aggregate maximum bitrate, AMBR.
Let's have a look on Home Subscriber Server, HSS.
The Home Subscriber Server, HSS, is a key element of LTE and IMS core networks. It is a master user database that is stored in one single node. It allows communications service providers, CSP, to manage customers in real time and in a cost-effective manner. A centralized database of subscriber information ensures that signaling is separated from the policy. As a result, it helps CSP ease their data center load, so they can achieve more efficient performance and greater streamlining of their networks. HSS allows CSP to perform specialized functions such as borrowing of certain services and functions, activation and deactivation of SIM cards, and the creation of a hierarchical segregation of subscribers based on their subscriptions. The role of the HSS is to communicate with the network and provide subscriber profile and authentication information. The database stores information about subscribers to help in the authorization, details of devices, as well as the user's location and service information. The HSS relays this information to the network using diameter protocol, communicating with the Mobility Management Entity (MME) via the S6 interface. Combined with an authentication, authorization, accounting (AAA) server, the HSS ensures that an LTE network works with legacy or concurrent services. The HSS also has the capability to communicate with the Wi-Fi infrastructure, which gives operators the ability to generate revenue streams with the creation of Wi-Fi hotspots and Wi-Fi offload. Further, as it supports roaming to non-3GPP networks, CSP can increase the reach of their networks. On being queried by the interrogating call session control function, ICSCF, when a user performs SIP registration, the HSS retrieves the address of the serving call session control function, SCSCF, and assigns it to a user. The user's information and profile data are then downloaded and stored by the HSS, from where they could be accessed.
Let's have a look on Policy and Charging Rules function, PCRF.
The Policy and Charging Rules function, PCRF, is a node which functions in real time to determine policy rules in a multimedia network. It is a component that operates at the network core and accesses subscriber databases and other specialized functions, such as a charging system, in a centralized manner. The PCRF has an increased strategic significance and broader potential role than traditional policy engines, due to its working in real time. PCRF provides the ability to manage network and subscriber policy in real time, the ability to efficiently and dynamically route and prioritize network traffic, unified view of subscriber context based on a combination of device, network, location and billing data, key inputs to revenue assurance and bandwidth management. PCRF plays a key role in VoLTE as a mediator of network resources for the IP multimedia systems network for establishing the calls and allocating the requested bandwidth to the call bearer with configured attributes. This enables an operator to offer differentiated voice services to their users by charging a premium. Operators also have an opportunity to use PCRF for prioritizing the calls to emergency numbers in the next-gen networks. PCRF is an important element in Service Provider Information Technology, SPIT. The PCRF interfaces with the main packet gateway and takes charging enforcement decisions on its behalf. The centralized device can act as a policy decision point, PDP, for the wireless operator and gets as granular as individual subscribers. For example, service providers can use PCRF to charge subscribers based on their volume of usage of high-bandwidth applications, charge extra for QoS guarantees, limit app usage while a user is roaming, or lower the bandwidth of wireless subscribers using heavy bandwidth apps during peak usage times.
Let's have a look on IP Multimedia Subsystem, IMS.
The IP Multimedia Core Network Subsystem, IMS, is an architectural framework for delivering IP multimedia services. The user can connect to IMS in various ways, most of which use the standard IP. IMS terminals, such as mobile phones, personal digital assistants, PDAs, and computers, can register directly on IMS, even when they are roaming in another network or country, the visited network. The only requirement is that they can use IP and run SIP user agents. Fixed access, for example, digital subscriber line, DSL, cable modems, Ethernet, mobile access, for example WCDMA, CDMA2000, GSM, GPRS, and wireless access, for example, WLAN, WiMAX, are all supported.
Thank you watching the video. Please like the video and subscribe to the channel.